In this question, we're going to use the property involving equal chords and some properties of triangles learned at the junior secondary level to find an unknown angle. To answer this type of questions, we should first observe the figure carefully and set up the answering strategy. In the figure, A, B, P, C, D, D, E, M, F, and A, G, and F are straight lines. Also, OM is perpendicular to DF, ON is perpendicular to AF, OP is perpendicular to AD, and angle AFD equals 78 degrees. If the lengths of line segments BC, EF, and FG are the same, what is the value of angle AOD? In this question, we're given a circle with some chords of equal length. Then we have some triangles with right angles. It's very likely we're going to make use of these information. Now let's focus on triangle AOD first. To find angle AOD, what do you observe? Do you notice that if we found the sum of angle OAD and angle ODA, we could find angle AOD? This seems promising. Let's give it a try. To make things simpler and clearer, we let angle OAP be x and angle ODP be y first. The only angle given by the question is angle AFD, which is 78 degrees, and its association with x and y is in triangle ADF. So we probably need to know something about angle OAF and angle ODF also. Let's see what we can find. We know that BC is equal to EF and is equal to FG, and we learned that equal chords are equidistant from the center. So we have OP is equal to OM and is equal to ON. Then consider triangles OAN and OAP. Angle ONA and angle OPA are both right angles. OA is a common side, and ON is equal to OP. We have a pair of right angles, a pair of hypotenuse with the same length, and a pair of sides with the same length. Therefore, we can prove that these two triangles are congruent, and the reason is RHS, right angle hypotenuse side. Given the two triangles are congruent, angle OAN will be equal to angle OAP, that is x. Similarly, we can prove that triangle ODM and triangle ODP are a pair of congruent triangles. And angle ODM will be equal to angle ODP, that is y. Now we can turn our attention back to triangle ADF. The sum of angles of a triangle equals 180 degrees. So x plus y plus y plus 78 degrees is equal to 180 degrees. Solving it, we have x plus y is equal to 51 degrees. Then turn our attention back to triangle OAD. The sum of its angles is equal to 180 degrees, that is x plus y plus angle AOD is equal to 180 degrees. We've already found that x plus y is equal to 51 degrees. So we've got the answer that angle AOD is equal to 129 degrees. There is almost always an alternative approach to a geometry question, and this one is no exception. Let's suggest one here. First, let angle AOP be A and angle DOP be B for easy referencing. Then angle AOD will be the sum of A and B. Using the same approach as before to prove that triangle OAP is congruent to triangle OAN, then we have angle AON is equal to A. Similarly, we can get that angle DOM is equal to B. The sum of interior angles in a quadrilateral is 360 degrees. So angle NOM is equal to 360 degrees minus 90 degrees minus 90 degrees minus 78 degrees. That is 102 degrees. Finally, we know that the sum of angles at a point is, again, 360 degrees. We get that 2a plus 2b plus 102 degrees is equal to 360 degrees. Therefore, a plus b is 129 degrees. That is, angle AOD is equal to 129 degrees. That's it.